and I will attempt to convince you that a few patterns are emerging here. The first pattern is that uh, I have circled the boxes out of 7 plus 7 plus 7 plus 6 microstates that I did, so 21, 6. Out of 27 microstates, only 4 have 3 particles in one energy level and 1 particle in another. All of the other microstates, so that would be 23 of them, have 3 different energy states with particles in it. And so what I would suggest to you is that that is a dispersal of matter thing, meaning when there are more microstates, there's higher entropy, and it's more probable to have the particles spread over more microstates. And then the other thing that's starting to develop, which I didn't know until I saw this, well, remember, this, I told you, if you end up with enough particles, starts to look like this. And if we were to do a plot of 1, 2, 0, 1, 2, and 3 energy levels and the fractions, what we're starting to see is that the states with particles in low energy, then 1 and 2, and then 3, you would start to see this distribution forming even with only 4 energy states. Anyway, it's a fascinating idea. Hopefully your example, which I know will be more simple than the one I'm doing. I'm actually really interested, and I will probably come back to this and complete it and see what I find. Another thing you can do, and I actually had my students do this once, we actually flipped coins and counted how many heads and tails we got to see statistically how many you should get. Anyway, there's lots of ways to look at statistics, but it turns out that if you flip 100 coins, you should get very close to 50 heads and 50 tails, but you'll also get some 49s and some 48s. Anyway, it's a fascinating topic. I don't want to spend any more time on it than we have to, though, to make sure that you understand these statements right here. Particles in more energy levels equals more matter dispersal and higher entropy, and more microstates equals higher entropy equals more probable. Any questions about that?
I have a question, Professor.
Go ahead, Zeldin.
So the problem that I have is like basically it's got the 2 bulbs and then it has 5 particles in one, and then we're supposed to draw out all the different states.
Yes.
What would you like? I guess what I'm asking is, what is a configuration? I guess in that terms, do we count it as like when all the particles are on one side and then all the particles on the other side as like one configuration?
Those
Or is
would
that two
be
different configurations?
those are 2 different configurations.
Okay.
And you said you had 5 particles, Zeldin?
Yeah, one, and the first one's already done for us, which is all the particles on the left.
Yeah.
And then I drew out all the different ones with the other states.
And hopefully what you found, Zeldin, is that there are 2 states that are most probable, 2 and 3,
Yeah,
and 3 and 2.
that's exactly what I found.
Exactly. And that 1 and 4 was more probable than all 5 in one of them, but less probable than the 3s and the 2s.
Yes.
Exactly. And I know, so that is exactly what I want you to see. And again, these are just very tiny examples of how microstates work. I think I chose perhaps slightly too complicated an example here, but all of these examples do show the same thing, which is the more microstates, the more probable and the more evenly distributed things are. So anyway, it sounds like you got it right on, Selden. Does that answer your
Okay, I just
question?
wanted to make
Yeah.
sure. So, like when I'm doing, it asks for the highest entropy,
Uh-huh.
and when I do that, should I circle both the 2 column and the 3 column since they're both equal, since they have the same amount of microstates?
Yeah, no, and I can see like there are different ways of counting them where you would count the the just one particle, or sorry, 5 particles in one bulb as one state, but let's count them as 2 different states and just say that
Okay,
2 and 3 and
three
three
and
and
two.
two are the most probable.
Okay, sounds good.
Yeah.